Reasons behind Hurricane Milton in Florida 2024. Hurricane Milton, which struck Florida in October 2024, was primarily driven by natural factors such as warm sea surface temperatures, low vertical wind shear, and favorable atmospheric conditions. However, the storm's intensity and rapid development were amplified by human influence factors like climate change, which has led to warmer ocean waters and increased atmospheric moisture. This created the perfect environment for a powerful storm. Below, we delve into the reasons behind Hurricane Milton's formation and its devastating destruction. 1. Warm sea surface temperatures. Warm sea surface temperatures played a crucial role in Hurricane Milton's development. In 2024, the Gulf of Mexico experienced abnormally high sea temperatures, exceeding the 26 degrees Celsius threshold necessary for hurricane formation. This warmth provided the storm with ample energy to intensify as it moved toward Florida. The Gulf's waters served as a fuel source for the hurricane, causing it to strengthen rapidly as it traveled closer to land. The combination of high sea temperatures and the storm's low-pressure system allowed for the rapid development of Milton from a tropical depression into a Category 4 hurricane within a short time. Climate change has exacerbated the warming of the world's oceans, making storms like Milton more intense. 2. Low wind shear. Wind shear, or the change in wind speed and direction with height, can either inhibit or strengthen hurricanes. In Milton's case, the atmospheric conditions featured low vertical wind shear, allowing the storm to grow without being disrupted. Low wind shear conditions in the Gulf of Mexico in 2024 provided Hurricane Milton with a stable environment in which to intensify. Without strong winds to disrupt its vertical structure, the storm maintained a tight, well-organized core, enabling it to strengthen rapidly. This lack of wind shear, combined with favorable atmospheric conditions, allowed Hurricane Milton to retain its strength as it approached the coast of Florida. 3. Climate change and rapid intensification. The intensification of Hurricane Milton was exacerbated by the effects of climate change. Warmer ocean waters, a byproduct of rising global temperatures, provided the storm with the energy needed for rapid intensification. Climate change has also led to increased moisture in the atmosphere, which results in stronger storms and heavier rainfall. In recent years, scientists have observed that hurricanes are intensifying more quickly and becoming more destructive. Hurricane Milton's transition from a Category 1 to a Category 4 storm within a short time is an example of this rapid intensification phenomenon. This left little time for Florida residents to prepare or evacuate, increasing the storm's destructive potential. 4. Geographical and seasonal vulnerability. Florida's geographical location makes it highly susceptible to hurricanes, particularly in the Gulf of Mexico and the Atlantic Ocean. The state is frequently in the path of tropical storms during hurricane season, and Milton followed a similar path. With its extensive coastlines and low-lying topography, Florida is highly vulnerable to storm surges, flooding, and wind damage. Coastal areas such as Tampa and Naples, located just a few feet above sea level, were particularly exposed to the hurricane's effects. Destruction. Related to Hurricane Milton, one storm surge and coastal flooding. The storm surge produced by Hurricane Milton was one of its most destructive elements. A storm surge occurs when the hurricane's winds push ocean water inland, leading to a rapid rise in sea level along the coast. Milton's storm surge, driven by its strong winds and low